All right, let's talk about what dot product means. So the scalar or dot product of two vectors A and B is written A dot B, that's how you say that, and is the scalar quantity given by A dot B equals AB times the cosine of the angle. Now that angle, like I said, with force times displacement in work, the angle is between the directions of or the vectors A and B. So whatever direction the A vector is in, and then whatever direction the B vector is in, say it's A's here, B's here, it's this angle between them. If B's here but A's here, it's going to be this angle between them. So it's the angle between the two vectors. And the scalar product is the product of the magnitude of one vector and the scalar component of the second vector along the direction of the first vector. That's all mumbo jumbo. Really what we want to know is that in unit vector notation, this is what it looks like here, where we have A dot B is equal to our A vector in unit vector notation dot the B vector in unit vector notation. Now, when we have something like this, right here, it's basically just a formula that makes it easier to do problems when they give you things in unit vector notation. So from appendix E in your book, I hat dot I hat and J hat dot J hat and K hat dot K hat, those are all equal to 1. However, I hat dot J hat or J hat dot K hat dot I hat, when you're not having a dot product between two similar direction vectors, unit vectors, then those are all equal to 0. So what we get here, how we would do a problem like this, is you would take your unit vector notation, and then all you would do is multiply your x component of the first vector by the x component of the second vector. You would multiply your y component of the first vector by the y component of the second vector, and multiply the z component of the first vector by the z component of the second vector, and then all you do is add them all together. All right, it seems really weird and almost too easy, but that's how you solve an equation with a dot product.